You like somebody, it's like, oh, they're gone.
Well, I got to the point where it was like I was looking up strategies and I'm like, what am I doing here? And I was like, I've gone with literally like basically no running backs. So I have 8 wide receivers. And I'm gonna try to just trade them out. That's what I'm gonna try to do.
Good luck. Let's see how that goes.
That's what, yeah.
Report back.
I will.
All right. Let me get the key up for you guys. Sorry, we're talking fantasy football. Come on. Oh, that's right. It was in that folder. That's stupid. Homework keys, section 2-3. There we're at. Oh, yikes. That looks like a bad scan. That's okay. Okay, sorry if you can't read that. Ooh. Let me go here. So number 17, that says mean 14.9, median 15, and mode 16. Looks like I wrote cluster between 275 and 285, I guess. And I said no outliers. Oh, this is one we were talking about. Somebody was asking me, are there outliers for this? Was it you?
I think it was me.
Yeah. That one, if you had said the highest value was an outlier, okay. I will make it very obvious on any assessment. Okay? If it's an outlier, I'm going to make it a blatant outlier. Like something that's really far out there, something that's really weird. Okay? You're not gonna be guessing at it. You shouldn't be guessing at it. Okay, let me scroll it down a little bit. Here is 37. There's 44. Okay, that 44 looks like to me a weighted mean. So the balance is my X. My days is my W. Hold on. Mrs. Brown, she's going to yell at me for not taking attendance last period. Hi, Mrs. Brown. Good, how are you doing? Camden Jenkins. He's right here. Hey, where were you first period, Camden?
I was,
He was not here.
no, I was sleeping. I was at home.
Hold on a second. He wants to talk to you.
Oh boy.
That's never good when they say it. I'm trying to come up with something right now. At this point, you just gotta. You're trying to come up with a story like 2 seconds. Okay, he's got a concentrate. He's talking to Mr. Brown. He's giving silence. He's just can't do it straight. Number 44. Number 44 is a little weird. The weighted mean problems that we had done, were all about grades. And so that the sum of the weights ended up being like 100 or 1. In this case, the sum of the weights ended up being 31. So, yeah, and it's hard to tell right there, but that is a 3. Oh, yikes. So what is that, my answer? 449.21? I think. I better get my actual key out. I should rescan this key.
Yeah, we had 41.
Oh, for real? Oh, for real. Well, then that's... Okay. You had 41, which was a grade problem, which was a lot more easy than a lot easier. Yeah. Okay. Hey, can I do 41 real quick? Because apparently I did 44 on the key and not 41. Does that sound good? You alright, Camden? Camden, you good?
Oh, yeah.
Okay. So, here's the table from the book. We got homework, quizzes, projects or speech, and then your final. And we have scores, and then we have the weight. They're calling it percent of final grade. And again, this is number 41. Okay, so your scores are, you got an 85 on homework, an 80 on quizzes, 100 on the project, and 93 on the final. The weights, only 5% on the homework, 35% on the quizzes, 35% in the project, and then 25% was the final. Okay, so for this setup, again, for a weighted mean like this, the formula is sum of the XW's divided by sum of the W's. Right? There's our formulas. Sum of the XW divided by sum of W. Divided by U. Okay, now, XW's. I need to figure out what that is. Actually, I'm going to pull this down here. So I'm going to write XW here and make a whole separate column. Now, again, just like I did it in class the other day, I'm going to take my weights as a decimal rather than a percent. Because in the end, I don't want to have to add up and then divide by 100. I would much rather add up and divide by 1 because that's a lot easier because you don't have to divide by anything. So I'm going to take the percent as a decimal. 85 times 0.05. 80 times 0.35. 100 times 0.3, that's 35. And then 93 times 0.25. Okay, so we've got, put this over here for right now, 4.25, 28, 35, and 23.25. Okay, you can go away now. Now, that was the XW's, right? I created my new column. Now I'm going to find the sum of XW. The sum of XW is going to add up all these. 4.25, 28, 35, and 23.25. 99.5.
I think it's 90. That's what I got.
What the heck did I do?
32. It should be 23.
Oh, look. I inverted two numbers. Sorry. 4.25, 28, 35, 23.25. There we go. There we go. Much better. 90.5. Okay, now, again, if this were to truly have different weights to them, then I would be dividing that sum by the sum of the weights. But in this case, since I chose to do the decimal values of the weights, I would add up all those. It would just be 1. 90.5 is my answer. That is my weighted mean here. Okay. Bless you. If that was a sneeze, I don't even know. And then here is the rest of it. See, 40. Do you have to do 45? Okay, yes. 45 is a weighted mean that the weights don't add up to 100 or 1. So in that case, I've got the score and then the weight. I have my total XW, 2268, and then I divide by the XWs. Or sorry, excuse me, I divide by the sum of the W's, which in this case looks like it is 27. So I divide by 27 to get 84. You will have to do a mean of a frequency distribution, like that one, on tomorrow's quiz. You will have to do that. It is on the review sheet. I will do it today, but I'm just letting you know you will have to do something like 49. So it gives you the range of values. You find the midpoint of the class. You multiply the class midpoint times the frequency. Technically, your class midpoint is x. So you're going to take the class midpoint x, multiply it by your frequency f. Then you're going to get a whole new column of xf's. Then you're going to add up all your xf, which is the formula, sum of xf, divided by n, which n is the total amount for the frequency. right? So in this case, it was 30. So it looks like my XF was 1085. Yep. You take 1085 and you divide it by 30. Okay, any questions on the homework that we want to talk through or anything? Okay, can we do the review sheet now? Does that sound good to you guys? All right. Again, if anything is different, I believe I have updated all my copies, but if anything is different from what you see on the screen, just let me know. I'll take this, I'll try to catch it too. With the data from the chart below, find the relative and cumulative frequencies for each class. Easy one to do here is the cumulative frequency. Just add them up, right? So in this case, the cumulative frequency goes 5, goes 5, 8, add 3, 11, add 3, 14, 16, 17. Is that what you guys got? I'm doing this without a key, so if your answer is different from mine, please let me know. Because it's on the fly. All right, relative frequency. That's the percentage of the whole, right? And the reason I did the cumulative frequency first is because I have this value of 17 now. That's my total amount. Relative frequency is the percentage. So in this case, I have 5 in my first class divided out to the whole 17. So 29.4%. 29.4%. I would accept relative frequency as a percentage or a decimal. I don't care. 3 out of 17 will give me my next 3 classes, so 17.6%. Oops, not 16.6. Look at me invert numbers again. 17.6%. And then 2 out of 17. And then 1 out of 17. So that gives me 11.8%. And then, what's that last one there? 5.9%. Questions about that? Yes.
Would it be okay if I put 18% and 12%?
We just rounded to the nearest percentage. That's fine too. Yeah. Yeah. I would say, as a good rule to follow, just go, like if it's a percentage, go to the nearest tenth. Yeah. All right, take a look at number 2. Use the frequency polygon below to answer the following questions. What you have to pick up on here is that I even tried to bold it for you. A frequency polygon, if you go back in your notes and look at what the frequency polygon actually shows you, it's showing you the midpoint of the class as the x-axis. Those are the midpoints of each classes. Those are not the class boundaries or limits. Those are the midpoints of the class. Okay, and it is not showing cumulative frequency, is it? It's not showing it's not an ogive, right? It is just a frequency polygon. Okay, so in this case, I've got a 0, I've got a 6, no, this is a 10, up here looks like it's a 22, this is a 24, the one down here is a 16, up here looks like it is a 20 on the dot, down here looks like it's a 2, right? And then here's a 0. Okay, so let's add up all those. 6 plus 10 plus 22 plus 24 plus 16 plus 20 plus 2. Just double check that. 6, 10, 22, 24, 16, 22. 100. 100 on the dot. Which class has the largest frequency? Now, I bet you could point to it, right? But the trick here is giving the lower and upper class limits. I mean, we see it, right? Right there. But we have to figure out what the limits of that are. Now, remember, the x-axis is the midpoint of the class. So in this case, what I'm looking at here is 78 is the midpoint. We have to figure out what our limits are. Now remember, the class limits shouldn't touch, right? The class boundaries can touch, but the class limits shouldn't touch. Okay? The class boundaries can touch, but the class limits cannot. So in this case, like what is directly, if I was thinking about the boundary line here, the boundary between 75 and 78, Well, what's right in between 75 and 78? 76 and a half, right? That's the class boundary, which they would meet at 76 and a half. So if I was going to go with the class limits, I would say 77, right? 77. If you wanted to say 76.6, I guess sure. I'm just going to go to, this is where you have a little play. You have a little leeway. If the boundary is 76.5, then I know that a good limit would probably be 77. So the lower class limit here would be 77. Well, if the midpoint is 78, what's my upper class limit? 79. So that must mean I've got, the class limits is 77 to 79. That's the class. Which class has a cumulative frequency of about 16? Okay. Right? Here, the one with the 10 on it, right? Not this one. No. Because of the word cumulative, right? If I had just said which class has the frequency of 16, yeah, you would look at that one over here. But I said cumulative frequency. So I've got to add them up. So the 6 and the 10 combine to get the 16. So this is my class, the one I highlighted in blue there. This is my class that has the cumulative of 16. So here are my lower and upper limits for that. Okay, I'm going to use the same dimensions here. I went one below and one above for my limits. There's my midpoint at 72, so 71 to 73. Make sense? Picking out the limits is a little tricky. I understand that. But the trick here was recognizing that those are midpoints and then using those midpoints to generate what the boundaries and limits should be. Okay. Hey, another weighted mean problem. We've done like a bunch of these just in the past couple days. Same grading thing again, right? So my score is my X. My weight is my W. So I've got to find XW. I'm just going to add on to this table here. Okay, so homework. 72 times 0.12. 75 times 0.18. Tests. 80 times 0.2. I'm going to bring this over real quick. Copy these in. 76.5. Oh, no. Sorry. That was from the last problem. 8.64. 13.5. This is 16. Let's run the other one. 60. Ooh, looks like we stunk at the essays. This would be like me. I was awful at writing. 65 times 0.15. And 70 times 0.35. Okay, so 9.75 and 24.5. 9.75 and 24.5. Okay, now, again, the formula is sum of XW divided by sum of W. Okay, now again, the sum of W in this case is going to be 1. So sum of XW, let's just add up. 8.64, 13.5, 16, 9.75, and 24.5. 0.64, 13.5, 16, 9.75. Yeah, 72.39. Divide by 1, so just 72.39. Questions about that? Okay. All right, now, approximate the mean, right? Approximate the mean. Now, how do you know that you're going to need to do the mean, like on your formula sheet, how do you know that you need mean of a frequency distribution? Well, because I'm telling you to find mean, and I'm giving you the frequency distribution. You have to recognize that that table is a frequency distribution, so that should tell you what your formula should be. And again, the formula for frequency distribution is sum of xf divided by n. All right, sum of xf divided by n, where x is the something to do with the class, and then f is the frequency. Now, I have limits to my class, right? So I need to find the midpoint of the class. Okay, 20 to 23 is 21 and a half. 21.5, right? And then I just got to keep, now what is the class, what is the width here? I'm going up by 4s, right? So just keep that rolling. 25 and a half, 29 and a half, 33 and a half, 37 and a half, 41 and a half. Come on, 41 and a half. Yeah. Okay, so we find the midpoint, and now I'm going to take that class midpoint multiplied by my frequencies. So I'm just going to add another column. This one is really easy, 41.5. I need to calculate that. Okay, let's start rolling here. 21.5 times 5. 25.5 times 3. 29.5 times 3. 33.5 times 3. Oops. Okay, so I better get these over here before I lose it. 107.5. Sounds like a radio station. 76.5. 88.5. 100.5. And then we've got 37.5 times 2. 75. Oh, done. 75. Okay. So now I've got to find the sum of xf's, and then I'm going to divide it by n. Okay, sum of xf. Let's add all these up. 107.5, 76.5, 88.5, 100.5, 75, 41.5, 489.5. And then I'm going to divide it by my total frequency. What did I say my total frequency was? 17. 17. Divide by 17. So 28.79. There we go. Questions about that? Oh, plenty of time. Oh, thought I needed to rush a little bit. No, we got plenty of time. Okay, flip that over onto the back. Let's do mean, median, mode for the data set. Okay, the mean. I don't know why there's an A in there. 8, 8, 8. 2 10s. Oops. A 12, a 14, a 15, a 17, and then a 35. 929 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 92. Well, that's not right. Oops. Look at that. 810 in there. That's a big error. Okay, let me go back in there and change that. I'm going to insert a plus sign right there. There we go. 8 plus 8 plus 8 plus 10 plus 10 plus 12 plus 14 plus 15 plus 17 plus 35. Okay. All right. You know what's interesting? And I was thinking about this as I was typing in all of those numbers for the frequency distribution. You're going to find that a lot of statistics is doing things without error. Where the math may not be as difficult as other math classes, but the computation might be more difficult. Like, just punching in all your numbers and not screwing up. Just not miswriting a decimal place here or there. Just being like a robot, right? You have to think of it like you are a computer and all you are doing is just evaluating the things on the screen. So just be very, very careful with what you do. Check over your work several times. Make sure your answer is reasonable. Like 92.9 would obviously not be a good mean for that. But if I divide by 10, yeah, that makes sense. So mean is 13.7. My median, looks like I've been nice to you and put them in order. Okay, so what is my median here? 11, right in the middle. Median is 11. And my most number looks to be 8. Now, what is the best piece of information to use for the center? Well, the mode, no good. It's the smallest number. No way I would ever use the mode. The mean. Why would I choose the mean over the median? There's a reason. Why would I choose the mean over the median in this case? There's one big reason. I wouldn't say more accurate. Oh, I'm sorry, I said that backward. Why would I choose the median instead of the mean? Because of the outlier. Yeah, I'm sorry. I said it backward. I would choose the median over the mean because of this 35. Because of that right there. So median would be best because the mean is pulling the outlier. The outlier is pulling the mean away. Construct a stem and leaf plot and a dot plot for the following data. Okay, so it looks like my stems should be 4, 5, and 6. 4, 5, and 6. And my leaves are 1, 2 2s, a 3, a 4, and an 8. 2 1s, a 2, an 8, a 9, a 0, a 2, oops, sorry, I forgot a 1. A 0, a 1, 2 2s, and a 3. Don't forget to put a key. Yeah, I don't care what piece of data you use, but make sure you show that 4 line 1 is 41. Okay? People will lose points for not putting a key there. Don't lose silly points like that. Okay, dot plot. I range from 41 to 63. Okay, I range from 41 to 63. Let's say here's 40, here's 45, here's 50, here's 55, here's 60, here's 65. And I'll put little dots. I've got a 41 and two 42s. 41, two 42s, a 43, sure, a 44, a 48, two 51s, a 52, a 58, a 50, ooh, makes it a little bit closer to the 60. Right on the 60, a 61, two 62s, and then a 63. I'm just looking for them to be in like the ballpark of the right place. Pretty simple, right? Okay, number 7. A car dealership wants a pie graph of amount of cars sold in each quarter. In the first quarter, 450 cars were sold. So in Q1, 450. In Q2, 685. In the third quarter of business, we got 267. And in the fourth quarter, 975. Everybody waits to the end of the year to buy a car. Be sure to label all categories, construct the pie chart. Okay, so for the pie chart, I need to find relative frequencies, right? I need to find percentages and then apply them to the circle. So I need totals. I got 450, 267, oh, forgot my 685, and then a 975. So my total is 2377. Just double checking that. 450, 267, 685, and 975. 450, 685, 267, and 975. Okay, perfect. So I got 2377 as my total amount of cars. Let's find relative frequency. Okay? So I have 450 out of 2377. I have 685 out of 2377. I've got 267 out of 2377. And I've got 975 out of 2377. So there are my percentages. Okay. So I've got 18.9%. I've got 28.8%. Got 11.2%, and then 41% flat. Okay, now I'm going to take those values and then I'm going to show them as degree measures. So I'm going to apply those values to 360. 0.189 times 360. 0.288 times 360. 0.112 times 360. And then 0.41 times 360. Okay, so my degree measures. Okay. My degree measures are 68, and you can round it to the nearest degree. 104, 40, and 148. Because again, I'm just looking for it to generally be correct. Get back at that. All right, so I've got 68 degrees as my quarter one. All right, so let's say 60 degrees somewhere right there. Looks about right. A little bit more than 45. There's Q1 at 18.9%. Let's color code this. Let's do 104 degrees. So a little bit more than 90. Right, 104 degrees. I'll go down this way. Why not? Don't really care where you put it. There's Q2 at 28.8%. We got 40 degrees here. So just past, we'll go here. 40 degrees, 45, somewhere around right there. There's Q3 at 11.2%. And then the rest should be Q4. Put it in purple. Q4 at 41%. Just under half. Yeah, that makes sense. Questions about that? I will be checking the work to see the degree measure. So please show that. Right? Don't just ballpark it with the percentages. Please show the degree measure. All right. And our last one. Draw an example of skew left, skew right, and symmetric. Place and label the mean, median, and mode. Okay, so let's go symmetric here. Let's put skew right over here and put skew left over here. Okay. Obviously symmetric, bell shape, right? Where is the mean, median, and mode? Right down the center. Right. So here would be the mean, the median, and the mode, all directly at the center. Now remember, skew left means pulled left. Skewed right means pulled right. It's where the outliers are, where the outliers exist. So if I say skew left, that means the tail is off to the left. If I say skew right, that means the tail is being pulled to the right. Now, let's correctly place the mean, the median, and the mode. The nice part here is that the mode is really easy. It's always right up at the top. Here's the mode. Here's the mode. Now remember, the mean gets pulled away toward the outliers more than the median. So I'm going to put the median here and then the mean here. The median and then the mean here. Here's the median, here's the mean. Does that make sense? You can label it on top, label it on bottom, I don't care. Just tell me where each piece is falling. What I'm looking for here is not necessarily where it's at on the bell curve, just the order in which the things go. Remember, the mean is going to get pulled away toward the outliers more than the median does. So that if it's a skewed left, the mean should be furthest left. If it's a skewed right, that means the mean should be furthest to the right. It means the mean. All right. Are there any questions or anything that anybody would like me to talk through again on this review sheet? once. Or twice.
Oh. All right. So long, everybody watching at home.